Hello and welcome to this machine learning demo of SnapLogic. We're going to have a look at how to predict house prices using the AutoML capabilities within SnapLogic. My name is Linus Akason and I work as a senior solutions engineer within SnapLogic. So we're not going to go into the details of all the different machine learning capabilities within SnapLogic. We're mainly going to be focusing on regression and classification types of problems. And this slide is to introduce the various kind of levels or approaches there is in SnapLogic to tackle a machine learning model training and prediction problems. So if you're really comfortable and advanced when it comes to data science and machine learning, you might already have some TensorFlow or PyTorch libraries in Python or other languages that you would like to see reused, or you might have those skills in-house and you want to capitalize on that within SnapLogic. So on the left-hand side, you have the coding approach. So that's basically bringing that code that you already have, or obviously also allowing you to create new Python scripts, etc., and use that as part of SnapLogic pipelines. So we provide a remote Python script snap that basically allows you to bring whatever libraries and Python frameworks that you may have and execute any type of code wherever you see that fit, but still use that execution as part of a SnapLogic pipeline, utilizing and combining that with the power of other SnapLogic capabilities like data integration or application integration. So that gives you a very flexible approach, but it might not be the right fit for all customers out there. So we provide, so kind of in the middle here of the page, highly customizable machine learning snaps. So for instance, we provide the trainer and predictor regression snaps that allows you to very fine-grainedly specify the advanced properties that's going into training and predicting with those models. Now, the third option that we're going to focus on in this particular demo is called AutoML, which basically automates some of the tuning and selection when it comes to defining a data set and actually getting the right algorithm and machine learning model for that particular data set. So that comes with a snap called AutoML, which will be the center of our upcoming demo. Now, on the right-hand side here, as we kind of go from a coding to more a AutoML scenario, it gives us more speed and also abstracts away some of the complexity involved in creating and using machine learning models. So for the demo, on the left-hand side, we will introduce our use case. So we already have a data set in Snowflake with a lot of sold properties in Brazil. So that includes the price of that cell, the number of rooms for the property, how large is that particular property, what date was it sold, what type of property was it? Was it a store? Was it an apartment? Was it a house? And what location in Brazil was it? Was it in Rio de Janeiro, or was it in another location within the country? And our goal is to, given a new property listing, so something that hasn't been sold yet, what is the predicted selling price of that property based on the other factors of that property? So again, size, number of rooms, date, etc., where we don't have the price yet. So that's our unknown parameter that we would like to predict. So to do that, we're going to create three different pipelines. So the first one is more of a helper pipeline. It's going to help us to write HTML data to an S3-based website. So essentially, our other pipelines will output some HTML that will help us as a data scientist to understand what our machine learning pipelines are doing in terms of what is the data set looking like and what are the different machine learning models that our pipelines are comparing and potentially using as well when it predicts values. So this allows you to, this allows us to get a visual way of looking at that data. Now, the second pipeline is the one that will be doing most of the work. It will be the one that creates and updates potentially our prediction model that we'll be later using to predict values. So we're going to use a couple of SnapLogic machine learning snaps in this pipeline. We're going to use a type converter to make sure that we have the right data types on some of the data before it gets fed into the model. we're going to use the profile snap in order to create a profile that can help us to clean the data set before we train the model. So with that, we're also going to use the clean and missing value snap to define what we should do in case some data is not fulfilled. So it might be, things that are missing out. It might be that we need to create new values on the fly, and we're going to use the data from our profile snap in order to help that logic come to life. And then finally, of course, we're going to use the AutoML snap to generate a regression-based machine learning model that we're going to use later on to predict the prices. So that's what we're going to do in the third pipeline. So simply, we're going to provide some sample data of new properties in Brazil that hasn't been on the market yet. And we're going to feed that data into a predictor machine learning snap that also has access to the model that has been created in the second pipeline. And the result of that third pipeline will be an output where we will have the predicted price for each of those properties that we want to understand the price for. So with that, let's jump straight into our machine learning pipelines right here. So as I mentioned, we have 3 different pipelines, and I just quickly want to go through them. We're not going to waste any time creating them all from scratch, but what I will do is I will go deep into the settings of every snap to make sure that there's a good understanding on whatever snap is doing as part of the pipeline. Now, this one here is not really related to machine learning, but I want to cover it off either way. So this is our helper pipeline that basically takes an HTML input and writes it into Amazon S3 as part of a static website. So first what it does, and this is really related to how Amazon S3 static website bucket works like, is we need to specify our content types. In this case, we're specifying text HTML. And in the second part of our pipeline here, we're using a document to binary snap. So in this pipeline, we will obviously get a document. So basically the HTML as a JSON file specifying what data we should convert into an HTML file. So as part of this pipeline, we have configured a parameter. So this pipeline needs to be called by another pipeline, including a file name. So that is essentially what will be uploaded to the S3 bucket. So by default, we're using a file name called model.html. Now, the third snap here, what it does, it basically takes that data that comes into this pipeline, and when it has been converted to a binary file by the document to binary snap, it's going to upload that to a static S3 website bucket. So that's what it does. So we're going to see how that is actually being utilized in our second pipeline. So let's go into this one because this is the one that's going to do most of the work. So this pipeline here, let's zoom in a bit so we can kind of go through in detail what every snap does as part of the process. So the first thing we do is we're using a file reader snap in order to get, potentially if we already have a model that has already been created using this pipeline. So in this case, I'm looking for a file called mymodel.json. That's how SnapLogic saves down machine learning models built within SnapLogic. So there's 2 different actions that can happen here. So one is that we do not have a file. If that's the case, it's going to go to this error route here, which will then jump to this union state right here. Now, if we do have a model already, we're going to take that file, the binary file, and we're going to parse it into JSON because that's how we want to work with the file later on. And then we use a copy snap to either go back to the union here or to go to another state here, which we're going to come to later. So for now, there's basically 2 different ways. Either we don't have a file, we're going to come here, or we do have a file and we're going to come here. So either way, we're going to come to this state right here. So the real first thing that we're going to do as part of this pipeline is we're going to go to Snowflake, which is obviously a data warehouse. We can also, use data warehouses in Google BigQuery. You can use Redshift. You can use, any type of source of data that we want to feed into our data set. But in this case, we're going to use a Snowflake execute snap in order to get that Brazil property listings in order for us to create a model to use for predictions. So what I'm doing here is I'm saying, okay, give me all the square meters, the rooms, the price, the created on date, the property type, and the place name and the state name from that Brazil property data set. And obviously we can go into the validation because we just validated this pipeline right here. So you can see, okay, give me, the first 100 records of that actual data set. And I can go into the table format here and I can see, okay, here's some different properties, actual properties in that data set. Now we can see that some of the data here is not really valid. Some data is missing. We can see that the number of rooms and actual square meters are missing from some of the various properties. But other than that, we can see, there's some house properties, there's some apartment properties. It's in various states and places in Brazil. And here's the selling price of those properties. So the next thing we want to do is we want to make sure that the type of those different values are right before we kind of move forward in our cleaning process of the data. So specifically, I'm going to use a machine learning data preparation snap called type converter that basically allows me to specify that, hey, I always want the price to be in decimal, I always want the rooms to be in integer, and I always want the square meters to be in decimal. And the reason why I do this is, first of all, we can't really trust that the data that we get back is always going to be the same. But more specifically, if we change the underlying data warehouse to, let's say, Google BigQuery, we cannot necessarily trust that the data types and the conversion between the data types are always the same. So that's why I'm always here going to use this type converter just to guarantee that I'm always getting the right data back from my data set. All right, so now we can see kind of the rooms are in this decimal format right here. The next thing I'm going to do is I'm going to use a copy snap in order to get this data set into two various streams. Now with the bottom stream here, what I'm doing is I'm using another machine learning snap of SnapLogic called profile. So this is part of our machine learning analytics snap pack. Now what this one does, it basically takes the incoming data and it creates two various outputs. So the first one is basically a JSON array of the profile of that data. So if we go in here to the output of the data, we will see that for each data type in our data set, it's going to calculate a mean, max, min, standard deviation, and also various popular examples of data in that data set, unique values, etc., etc. What it's also going to do is going to create another output, which will be an HTML. That's going to represent a more visual approach of that same data that we just saw here in JSON. So that one is going to a pipeline executes. If I open this up, you see here it's going to our pipeline that we covered earlier that's updating that static file in S3. And here I passed the file name parameter. If you remember, we required that file name to be part of the parameters when we passed to the pipeline. And here I'm specifying the name of that file as profile.html. So if I open up that S3 public bucket site, and I can go to this profile here, that's giving us the profile.html, which is what we just uploaded. We will now see a visual representation of that exact data that we just saw in JSON. So I can go, for example, into property type, and I can see, okay, actually 4,900 apartments and 4,871 are houses, and just a few are the type store. So it gives us a visual representation of the data that will eventually go into our machine learning model creation. So going back to our pipeline here, let's follow the upward stream where we actually get the profile JSON data, and that's get fed into another machine learning snap called clean missing values. That is part of our machine learning data preparation snap pack. Now, this particular snap requires two inputs. One is the actual profile JSON data that we just showed from our previous profile snap. And the other input is obviously the data set itself. So what this is going to give this snap is the ability to say, okay, if there's any missing data as part of the data set, why don't we take a specific action? So here we're saying, as part of the policies for the clean missing value snap, we're saying, okay, you know what, if the price is missing, just drop that particular row entirely. And the same for if the state name or place name is missing. However, if we're missing the created on date, we're gonna instead here say that if that is missing, impute with a custom value that is using the JavaScript function dateNow. So that says that if a row is missing the date, do not throw that away. Instead, create a new date, which is the current time, and keep that data in our data set. Now, Some of these examples here might not be necessarily what you would like in a production scenario when you clean out data for your machine learning model. But in this case, just to show the different capabilities, this is what we're going to do. So with the property type, if that is missing, we're going to use the most popular value. And by looking at the profiler here, we're going to see that, okay, then it's automatically, in this case, going to take the property type as apartment. And with rooms, we're going to say, if the rooms is missing, don't throw the row away. Instead, use the average value based on that profile data that we've already generated. So that might be 2, it might be 3, depending on what the data set has for the most average, the average value of the number of rooms. And then finally, I'm going to say that if we don't have the square meters, we're also going to drop the row. So if we now explore that data set after we have cleaned the missing values, we're going to get a bit less data, obviously, but the data will be cleaned out of null values. So we see here, for example, that we're using the average of the number of rooms. Now, again, this might not be exactly what you would like in a real scenario, as this is not this is using the decimals, and we might want to use an integer instead. And some of the dates you would potentially see here would have so all of these in the sample here actually do have dates, so we haven't cleaned them out, and we are not passing through any rows that do not have a place or state. All right, so the most important snap here as part of this pipeline is our AutoML snap, which is part of our machine learning core snap pack. We're going to go through some of the settings here, not too much in detail, but again, the purpose of the snap is to abstract away as much details as possible from you as a user so that you can generate value in terms of machine learning model without having too much background in the space. So it's going to create a model if it's a regression problem or a classification problem by itself. So you don't have a property here allowing you to define if this is a regression or a classification problem. The snap will automatically, based on the data set, understand what type of problem we're trying to solve. For both use cases, though, it's going to ask us for a label field. Now, the label field is basically telling the AutoML snap what particular column or field it should be predicting the model for. So basically, in our case, we have a regression problem, a forecasting problem, or a prediction problem, and we want to specify that what we're after is the value of the price. That's what's going to be important for a model. Now, the time limit and number of models basically tells the AutoML snap how long and how many models it should try to generate based on the algorithms that we provided it. So in this case, we're saying, okay, we only want to do this for 9,600 seconds. If we haven't been able to create the number of models that we're asking for, then we're just going to stop. So if this was set to 800 models or something like that, we might just end up with 8 or 9 or 10 of them in this given time frame based on the infrastructure that we're running this execution on. So the purpose of the AutoML snap is to use a number of different models and compare them in terms of the least error, the least marginal error that the various models produce, and then it's going to automatically select the best performing model in terms of creating the final model file for us that we can use later on. So it also does the cross-validation of the data using the fold. So basically what the fold number does, it basically breaks down your data set into a training data set and a testing data set in order to test the performance of your model. The engine, we're going to come to that in a slide here to go through that a bit more. So if you have a look here on engine and algorithms, we see that we have selected HTO as the engine and standard XGBoost as the algorithms as part of this model. So going back to our presentation here, I just want to kind of give an overview of what kind of algorithms we support as part of this AutoML snap. So basically, there's two different engines to go by. One is HTO and the other one is Weka. In our case, we've selected the HTO engine. And we've also specifically selected that we're interested in standard and XGBoost type of algorithm. So both engines comes with 4 different families, essentially, of machine learning algorithms. So standard, tree, and XGBoost. And we have specifically said that we're only interested in algorithms for standard and XGBoost. Now, for standard, you can see that there's two different ones. There's generalized linear modeling and there's gradient boosting machine. And for XGBoost, there's XGBoost. So that basically means that when we say that we want to have this engine, these algorithms, and these number of models, the AutoML snap will essentially create, if the time permits, 8 models based on these 3 different algorithms. So again, XGBoost, generalized linear modeling, and gradient boosting machine. It's going to create, obviously, since we're having 8 models, it's going to use some different variants in terms of the folds. So the AutoML snap basically outputs 3 different outputs. So the first one is obviously the machine learning model itself as part of a JSON document. The second one is a comparison in JSON of those models that has been created. Now in the validation mode, even though we've specified 8 models, we're only going to get 5 back as part of us executing this snap in the validation mode. So here we can see that it has selected for the 5 best models XGBoost with different folds for the top 4, and then a generalized linear model as the 5th one. What we also output is the HTML. So exactly as in the same concept as for profile data, it's going to output HTML to get us a visual representation of what those models and the performance of those models would look like. So if I open up again here my S3 bucket and I go to the model HTML, now we're going to see those same models. And here we actually see 8 because we only execute this AWS S3 pipeline in the execution mode and not the validation mode. So we get 8 models here, and we can see, the mean square error for the models. We can see the sample size, etc., etc. We can kind of get a visual representation on how our different models are performing. Now, the mean average error here is essentially the price error between the test data and the actual data in the data set for the model. So this basically says that 57,000, more or less, is the average error in terms of predicting property price for a listing. Now, coming back to our pipeline here, what we do with the actual model that we have here in JSON is that we essentially just convert it into a binary file, and then we save that as mymodel.json. So if you remember in the start of this pipeline, we basically said that if we have a model, we want to use a copy snap to get 2 different streams of it. So one obviously went into here and got the data from Snowflake and then went on and trained the model. The other one, though, also goes to the AutoML snap. So what we're saying here is that if we do have a model, we want to pass that model in to the AutoML snap as part of the actual clean data set. Now, that basically reduces the time it takes to train a model because it uses an existing model and essentially just enhances that model with the new data as part of the data set. So let's explore our third pipeline, which is then used to use that model to predict prices for new properties in Brazil. So the first step I'm using is just a JSON generator to generate some new properties. So I'm saying, okay, this property is 50 square meter, it has 2 rooms. I'm just adding a comment here just for my own sake. So I'm saying here, this is a small house in Kotia. I'm adding a date. I'm saying this is a house, it's in Kotia, which is in Sao Paulo. So I have a couple of various properties here that I've just made up some details on, and I want to get the predicted price for each of those properties. Now, if you look in the bottom here, I'm using another pipeline execute that goes to our other pipeline to retrieve that model. So the return of our other pipeline here is basically our model in JSON, okay? So we're getting that and we're saving that as a file. Now, what we could do obviously is to not load this from the other pipeline. We could load it from a file system instead, and we can say that I want to retrain the model every hour or every day or whatever it might be. But just in terms of this demo, I'm always retrieving the latest and greatest model from other pipeline. So I'm taking that model in JSON. I'm also taking my original data. I'm copying it into 2 streams. So let's focus on the bottom stream. It goes into a new kind of machine learning snap. That's called a predictor for regression problems. Now that takes 2 inputs. It takes the actual data that we want to predict the price on. And it also takes, obviously, the model on what to base our prediction on. So that's the only two settings that this takes. So the output of this predictor will be the projected prices for each of those properties that we have asked for. Now, the reason why we use a copy snap to get it into two streams is so that we can join it back with the original data after it has created the predictions. Because after the prediction comes out, we only get the predicted price and not the original data of those properties. So when we join that back with the original data set, we will now get a much nicer looking and understandable data with all the original data fields, as well as now the tied prediction for those properties. And then I'm just using a sort snap to sort that data in descending order. So, we might create a leaderboard, we might, raise a JIRA ticket for the property that, has the highest expected price or something like that. All right, so just to wrap up, what we've done so far in this demo is we went through a pipeline that basically just updates static files in S3 for our profiler and for our models based out of those Auto-ML generated models. So we got a visual representation. Then we look through our actual pipeline that creates or updates, if we already have a model, our prediction pipeline, where we use some of the machine learning snaps to clean the data and to then train a model to predict prices based on our regression problem. And then the third pipeline, we used some sample new Brazil property data that we wanted to predict the data on, and we used a predictor snap regression to take action and predict values based on that with the model as well. Okay, so that's everything from this machine learning model demo. Thank you very much for watching.